So based on continuity equation, I'm going to ask you a question. Let us say in this pipe system, in the first pipe system, yeah, there is a mass flow rate of 10 kilogram per second. Otherwise, water is entering this pipe with a mass flow rate of 10 kilogram per second. Yeah. So through pipe 3, let us say 4 kilogram of water is coming out every second, assuming of course there is no loss or stagnation of water. Tell me, what do you think would be the mass flow rate in pipe 2? What do you think? Excellent, it is 6 kilogram per second. Otherwise, my dear people, the mass flow rate that is entering the system, m dot 1 here because it's pipe 1, so m dot 1 should equal to the mass flow rate exiting the system. This is m dot 2 and m dot 3 because the pipes are called, yeah. So m dot 2 plus m dot 3, that's it. So if I write it based on the volumetric flow rate, I would write it as density 1 times volumetric flow rate v dot 1 equals m dot 2 is density 2 times volumetric flow rate 2 plus density 3 times volumetric flow rate 3. Yeah, but if you think of it, it's just water that's entering and exiting, and the density of water is not going to change from here, here, and here. So we have the next expression as well. V dot 1, the volumetric flow rate in, equals the sum of the volumetric flow rate out. That's it. Do you see how simple this is? So let us expand this one. Okay. Volumetric flow rate 1 is nothing but area 1 times the velocity 1 should equal to, area 1 is this cross sectional area here, yeah, and c1 is the velocity with which water is entering here, equals v dot 2 is nothing but a2 times c2 plus v dot 3 is a3 c3. There you go. It is as simple as that, my dear people. It is as simple as that. Yeah. Now look at this particular system. Here there is, this is an entry, this is an entry, and this is an exit. So I would like you to write, consider this as section 1, section 2, and section 3. Yeah. Can you write the equation for the mathematical expression for mass flow rate and volumetric flow rate? Can you do that in a sheet of paper that's next to you, or you can just write it, I do not know, wherever you want to. Before we solve a problem, okay, I want you to try writing the mathematical expression for this particular pipe. Okay, this is section 1, in which this area is a1 and the velocity with which water is flowing, it's water, okay, c1. This is section 2, area 2, and the velocity is c2. Water is entering here, a3 c3. Water is exiting here, a4 c4. And water is I do not know, what do you want, enter or exit? Let's say enter. A5, C5. People, can you please try writing the mathematical expression for this in terms of the volumetric flow rate and the mass flow rate, please? It would be so very useful. Yeah, try it, try it out, and you can tell me during the tutorial. Now I've got to find how to rub this off. Ink tools, erase all. Fantastic. Now let us solve this particular problem. What do we have here? In this problem, we have a pipe of inlet diameter 8 centimeter. So we know the diameter is 8 centimeter, and the velocity with which the water flows in. So we know it's water, okay? The velocity is 0.49 meters per second. So 0.49 meters per second. It branches into two pipes of diameter 6 and 4 centimeter. So diameter is 6 centimeter and 4 centimeter. And if the velocity at pipe of diameter 4 centimeter is zero point 0.6 meters per second, okay, zero point 0.6 meters per second, calculate the velocity in 6 centimeters pipe. So what would be the velocity? This one, yeah, I've written them as diameter 1 C1, diameter 2, diameter 3 C3, etc. Yeah, it's a very simple equation. I don't even have to solve it. I'm sure you'll be able to do it. But you know what? I'll just quickly do that. We know from continuity equation, yeah, volumetric flow rate in, which would be 1, V dot 1 equals the volumetric sum of volumetric flow rates out, in this case V dot 2 plus V dot 3. And I've just rewritten the equation. V dot is nothing but area times velocity. So that's what I've written here. Area 1 times velocity 1 equals area 2 times velocity 2 plus area 3 times velocity 3. All that I've done is that I've just expanded on them because it's a cross sectional area. The area, the cross sectional, the sorry, it's a circular cross section. The area is pi by 4 d square. So pi by 4 d1 square c1 equals, I've just expanded them. Pi by 4 is a common element, so I've cancelled them out. So rearranging the equation, I get c2 is d1 square c1 minus d3 square c3 divided by d2 square. All that I have to do now is substitute the values because we know all these values. No, substitute them, and then I get the answer C2 to be 0.604 meters per second. Otherwise, water will come out of this particular pipe with a velocity of 0.604 meters per second. This is what it means. Did you all get the same answer as well if you had paused the video and tried it out on your own? If so, well done.